right, before we move on to our second type of estimator, an interval estimate, let's talk about what it means to be a good statistical estimator. And it turns out that good statistical estimators have three properties. And the first is the biggie. We want it to be an unbiased estimator. The question is, what does it mean to be unbiased? So when we say unbiased in this context, what we mean is that the mean of the point estimates, the average of the point estimates, that we pull from all of the samples of a fixed size is equal to the parameter of interest. The parameter we are estimating. So if I am estimating the mean height of students at Rancho San Juan, I want the mean of all of the samples of size 20 to be equal to the population mean that I'm estimating. We know from the central limit theorem, if our samples are large enough, we know it's normal, we know that mean will be equal to the population mean. So that's good to know. We already have some confidence when we're estimating means from the CLT. The other two things we want are we want our estimator to be a consistent estimator. And what a consistent estimator means is that as the sample size increases, the value of the estimator approaches the value of the parameter we are estimating. What that means is I know that if I have a population of 1,600 students and I collect a sample of size 20, that sample mean is probably not going to be an accurate representation of the population mean. But as I make that sample size bigger, 50 students, 100 students, 150 students, 300 students, the bigger that sample size, the closer that sample mean will be to the population mean I'm trying to estimate. So bigger sample size means that sample statistic is getting closer and closer to the actual population value. The last is that we want it to be a relatively efficient estimator. What that means is that of all of the possible statistics that we could use to estimate our unknown population value, we choose the estimator with the smallest variance. And we know variance is related to standard deviation. Variance is a measure of spread. So we want to choose a sample statistic that has a small spread about the unknown population parameter. So we want the standard deviation of the sampling distribution, or the standard error, to be small. That's what characterizes a relatively efficient estimator. So our estimator should be unbiased, consistent, and relatively efficient. All of the estimators that we're going to be using are unbiased estimators. They are consistent estimators. They are relatively efficient. So you will not need to do these checks, but you should know what it means to be a good estimator. All right, if you have any questions on what you saw in this video, feel free to send me an email or drop by my office hours. Otherwise, I'll see you in our next video.